Hi friends, welcome to my channel. Let's have a look at problem 583, delete operation for two strings. In this video, we're going to explain a solution based on dynamic programming. First, I'll read through the problem statement to grasp the requirements, and then we do the analysis, and finally we share the code. So actually, this problem can be regarded as follow-ups for problem 72 and problem 712. You can actually make comparisons of these problems and so on. So with that said, let's first look at the problem statement. Given two strings, word 1 and word 2, return the minimum number of steps required to make word 1 and word 2 the same. Here in one step, we can delete exactly one character in either string. So here are two examples. So in the first example, the output is 2. So for example, we can delete S from the first one and T from the second one, right? So in example 2, so the required operation is 4. So you can actually do this. So here is ETCO, right? So we can delete LEDE in word 1. So there are 4 operations. So let's also look at the constraints for this problem. Actually, we can regard these constraints as additional assumptions. So first, the length of the two words are bounded below by 1. In other words, they are not empty, and the length is are bounded above by 500. So secondly, the two words consist of only lowercase English letters. So with that said, we are ready to look at the analysis. So as we mentioned here, we are going to solve this problem using dynamic programming technique. So this is actually a very common coding technique. So here for dynamic programming, so if we want to use tabulation here, so the DP interpretation is crucial. So once we set up the DP interpretation, and basically it determines the initialization and DP update rule together with the problem logic. So here for the DP interpretation, I'm going to choose to use dpij to represent the minimal number of steps to make S1 from the index I onwards and S2 from the index G onwards the same. So here I and J run in the range. So here I and J run in the range. So I is here from 0 and ending at length S1. So here J is starting from 0 and ending at length S2. So here I'm using S1 as word 1 and S2 as word 2. So with our interpretation, so the DP size is m plus 1 times m plus 1. So what we want to return is actually DP00. DP00 means for S1 starting from 0 and for S2 starting from 0. In other words, the two full strings. So with the DP interpretation explained, so we actually can look at the initial setup. So if I equals m, in other words the length, then S1 starting from I onwards is an empty string. And then to make S2J starting from J onwards the same as the empty string, we just need to delete the number of characters in S2J onwards. So this is in complete similarity with the case when J equals n. So we're not going to go into the final details here. So this is the second step for DP initial setup. So for DP update rule, so this actually we need to compare the two characters at index I and index J in S1 and S2 respectively. If the two characters are the same, and then so dpij equals dpi plus 1 j plus 1. In other words, we do not need to do operations here. So otherwise, so we're going to pick the minimum one of these two. So 1 plus dp I plus 1j. In other words, this 1 means we do a deletion of the character s1i. So the second item corresponds to do a deletion for s2j. So we want to pick the minimal of the two. So as we mentioned before, so we need to return dp00 according to our interpretation, right? So here are some walkthroughs for the two examples, and here we just need to specify the final state of the dp table. So this is the dp table for example 1. So 2 is the output or return. So this is the dp table final state for example 2, and 4 is the final output or return. So you can actually practice to write down these tables by yourself. So with that said, so let's look at the code. So for the coding, actually now it's very standard and routine. So we want to translate the above analysis into coding format. For this, first I'm going to get the length of the two words. So this is just for convenience. And then let's also make some dp table initialization. So here m plus 1 for a dummy index in the range m plus 1. So let me emphasize again here. So due to our interpretation, we use a m plus 1 by n plus 1 dp table. So let's call this one preparation, right? This is step 1. Now let's look at step 2. So initial setup for the empty string, right? So first I want to set up the mth row. So actually the index m row, we can see it's m plus 1 row. So for this, I'm going to iterate for j in range. So m minus 1, right? -1, -1. So we're iterating in a backwards fashion. So the dp m j. So we just need to count the number of characters in the string dp s2 j onwards, right? So this is 1 plus dp m and j plus 1. So this is the one case. Now let's look at the last column. So this for m in range. So m minus 1, -1, -1, and then dp I n equals 1 plus dp I plus 1 n. So these two for loops correspond to this second item here. So next, let's do the dp update for general case. So general setup. So we are going to iterate, right, for I in range m minus 1, -1, -1, for j in range n minus 1, -1, -1. So if let's first compare the two characters at indices I and j respectively. So word 2 j. If these two characters are the same, so we're going to set dpij equals the diagonal direction element dpi plus 1 j plus 1. And then otherwise, so we're going to pick a smaller one between two choices, that is 1 plus the mean. So either is dp I plus 1 and j. This is the downwards direction, and dp I and j plus 1. This is the element to the right. And this finishes the dp update. And finally, we just need to do the return. So let's see, do the return. So we're going to return dp00. So this return format and update rule is based on our interpretation. So actually, we can do the interpretation in a other fashion. So for example, ending at index I or ending at index j, or up to index I, up to index j. And actually, we can write the corresponding solutions similarly. So now, with that said, this forms a solution format for this specific problem. Let's first do a check. So here local variable I, so here is I. Yeah, it passes the second example. Now let's look at the generic case. Yeah, it passes all the generic cases. So with that said, I guess that's about it for this specific video. You are welcome to check out other similar problems in my DP playlist or general problem in our channel. So with that said, that's it. Thank you.